Okay, today we're going to solve system of equations, but instead of graphing like we did last week. So for example, last week we graphed an equation, graphed the second equation, and where they intersected was your solution. The intersection was the solution. What we're going to be doing today, we're going to find the solution, but we're going to be using the substitution method. Okay? So let's go through the steps of how to use the substitution method. Okay, so step number 1, we're going to solve either equation for one of the variables. So guys, I'm going to solve for this variable right here. I'm choosing that one because the rest of them have coefficients and that looks complicated. So I'm going to solve for x. So everyone go ahead and write this down. I want to move the negative 5y to the other side, so that this is going to be rewritten as x equals 5y, because I moved the negative 5y to the other side. The 13 is still positive. So I solved for x. That was step 1. I solved for one of the variables. Now, step 2, I'm going to substitute this expression into the other equation and solve. Okay, so guys, I'm going to write down the other equation right here. I'm going to write it down, but instead of x, I'm going to substitute the expression in there. I'll show you what that looks like. I'm going to substitute this because we're saying that x equals all of this. So instead of writing an x, I'm going to put all of this. Notice when you do that, we just have one variable. So now I just have y's. And now I'm going to solve for y. Okay, so I'm going to go ahead and distribute. This is negative 35y, and negative 7 times 13, what is that? 91. Negative 91 plus 8y equals negative 10. Okay, let's continue solving. So negative 35y plus 8y is negative 27y. I combine these two. Okay. And now I'm going to add 91 to both sides. So I get negative 27y is equal to negative 10 plus 91 is 81. Now you divide both sides by a negative 27. So I get y is equal to negative 3. Okay, that was step 2. We plugged this in to the second problem and we solved. We got our answer. Okay, now the final thing, we need to figure out what x is. So we're going to use substitution again to solve for the other variable. So guys, I'm going to plug this y right into here so we can figure out what x is. So I'll do that math over here. X is 5 times y plus 13. We just said that y is negative 3, so I'm going to plug in a negative 3. So this will become negative 15 plus 13. So that means x is negative 2. So guys, that is my solution. The x value is negative 2 and the y value is negative 3. This is where the two lines would intersect. Okay, let's go ahead and move on to this one. All right, guys, again, we're going to substitute. Okay, so guys, which variable would y'all like to solve for? X? Okay, we'll do x again then. So I'm going to move this over to the other side. So I have 3x equals negative 2y. If you move it to the other side, it's now a positive 2y. The 30 stays the same. Now we're not done. I'm going to divide by a 3. So we got x is 2/3 y plus 30 divided by 3 is 10. So this is my new equation. I transformed this one to become this right here. That's your step 1, solve for one of the variables. Now we're going to plug this in to the second equation. So I'm going to write that down. I'll write it up here. 7x plus 5y equals negative 17. And I'm going to put this expression where the x is. So 2/3 y plus 10. And then we'll solve. So let's go ahead and distribute. 7 times 2 is 14, so this is 14/3. 7 times 10 is 70, plus 5y equals negative 17. Okay, let's go ahead and subtract 70. So I get 14/3 y plus 5y is equal to negative 87. Okay, look here. In order to add fractions, everyone change this to 5/1. In order to add fractions, these denominators need to be the same. So I'm going to multiply this by a 3 and multiply the numerator by a 3. So what this becomes is 14/3 y plus 15/3 y is equal to negative 87. Okay, so we get 14 plus 15 is 29 divided by 3y equals negative 87. Okay, let's go ahead and solve for y. I'm going to multiply this side by 3, cross it out, multiply this side by 3. Can someone please type that into the calculator? Let me know what that is. 261, perfect. Now let's divide both sides by 29. Let me know what you get. 9? Negative 9, perfect. So y is equal to negative 9. Okay, so we found the y value. We found the y value. Do you guys remember what we do next? Yep, we're going to plug it in here to figure out what x is. So I'm going to erase this little y here, and I'm going to plug in a negative 9. So let's go ahead and solve that. 2 times negative 9 is negative 18, and it's over 3. What's negative 18 divided by 3? Negative 6 plus 10 is 4, so x is 4. So that is the point where they intersect. They intersect at 4, negative 9. This is where these two lines, if you graph them, they will intersect at this point. That is your solution. This is your solution. Okay, so we learned the substitution method. Next, I'm going to show you the elimination method. Okay, so flip over your page. I'm going to show you elimination method. There's 2 methods of solving these. Actually 3. You can graph them and figure out where they intersect. You can use substitution, which we just did, or you can do elimination. So let's try the elimination method. The first step is you need to align the equations. So here, these 2 equations are not aligned. Let me show you what it would look like if we made them aligned. I'm going to move this 5y to this side so that it will become 4x minus 5y, because I moved it to the other side, equals 10. Everyone go ahead and write that down. And the second one, we don't need to change it. I'll just keep it like it is. Now, my equations are aligned. Notice the x's are lined up, the y's are in the same column, the equal signs are lined up, and the numbers are lined up. Okay, so they are aligned. Okay, next. What I'm going to tell you guys to do is multiply your equations by something. Now, I'm going to multiply this. Everyone put parentheses around this top one. I'm going to multiply it by -2. And I'm going to show you why, but write it down first. -2 times 4x is what? Do you see how if I add these together, it would cancel out? That's called elimination. This is why it's called the elimination method. You can eliminate one of your variables, okay? But we could only do that when I multiply by a -2. -2 times -5y is +10y. -2 times 10 is -20. We multiply the entire equation by -2. Okay, now I'm going to add. So guys, I'm going to change this step 3. We're going to add. Okay, cross out this word same. We're going to do opposite. I like to do mine differently. They're not wrong. I'm just going to change it. We want opposite coefficients so that when you add them together, it will cancel out. Okay, so let's add. Let's keep adding. 9y plus 10y is 19y. 58 plus a -20 is 38. And now we're going to divide both sides by 19. So you'll get y is equal to 2. All right, we found one of them. Now, the final part is use substitution to solve for the other variable. I'm just going to pick one of the equations. I'll just pick this top one, the original. 4x equals 5y plus 10. Okay, this was the original problem. I'm going to put in a 2 for that y value. And then solve for x. So we'll get 4x equals 5 times 2 is 10, plus 10 is 20. And then you divide both sides by 4. So you get x is 5. So that is where these two lines intersect at, x comes first. They intersect at 5, 2. So these two lines will cross at 5, 2. Okay, so that's how you do the elimination method. Okay, I want you guys to try number, let's see. You guys try number 9. Try number 9. Okay, so this one, guys, I'm going to multiply this one by a 3, and I'm going to multiply this one by a -8. And let me show you why. 3 times 8x is 24x. And this bottom one, -8 times 3x is -24x. So you guys see how now those will cancel? Okay, so this is an example where you had to multiply both equations by something. Okay, but we still need to distribute for the entire thing. So 3 times -2y is -6y. 3 times -32 is -96. -8 times -11 is +88y. And help me out, guys. What's -8 times -53? +424. 424? Okay. All right. So we eliminated. Now we're going to add these together. So this will be 82y equals, what are these two added together? Sorry, say it again. 328, thank you. And now we're going to divide both sides by 82. And let me know what that is. 4? Did y'all get 4? Okay, nice. So y is equal to 4. So we found one variable. Let's figure out the other variable by plugging it into one of the equations. So which equation did y'all pick? I'll do the bottom one this time. It doesn't matter which equation you do. So I have 3x minus 11 equals negative 53. I'm going to plug in a 4. And you'll get 3x minus 44 is equal to negative 53. Add 44 to both sides. So you get 3x is equal to negative 9. And then divide both sides by 3. Did you guys get negative 3? Yes, nice. All right, so that's your point. These two lines intersect at negative 3, 4. Nice. Okay, now let me show you guys an example real quick that you might encounter. So let's pretend I have 2x plus 4y equals 17, and I have negative 2x minus 4y equals negative 17. Do you guys see that those cancel out? These cancel out. So on this side, I just have 0. And this side cancels out. What does that mean? There's infinitely many solutions, okay? If you were to graph this line, let's say it looks like this. That means this line right here is the exact same line. They're the same line. That's why they intersect at every single point. They share every single point. This previous example, they only share this point. However, if it's infinitely many solutions, they're the same line, so they share every single point. Now let's do a different example. Let's say I had something like this. 2x plus 4y equals 8. Negative 2x minus 4y equals 7. That cancels, so this side is just 0. 8 plus 7, that's 15. Is that true?
No.
No, so this one would be no solution. What do you know about the lines if there's no solution?
They don't intersect parallel.
They're parallel. So if you graph these lines never touch each other. That's why there's no solution. They're parallel lines. Okay, so you might see a case like this where there's no solution. Okay, so those are the different cases. They'll either intersect somewhere and you'll get a solution. They either are the same exact line or they never touch at all, so it's no solution. Okay, those are the 3 cases that you might encounter.